Okay, let's talk about independence or correlation. Here's a definition of independence and correlation. Independence is the joint event, meaning A happened and B happened, should be the probability of A multiplied by probability of B. Correlation is just the quantity of expected value of X minus average of X, like the mean of X multiplied by Y minus mean of Y, and divided by standard deviation of X and Y, or the square root of variant multiple of variant. The independence is stronger criteria, meaning you can get correlation equal to 0 if you have a complete independent probabilistic functions. But if the correlation equal to 0 doesn't mean they're independent. Here's an example. If we have a normal, like a standard normal distribution as x, and z as a function of negative z as a function that give you -1 and 1 with a half probability, and set y equals x multiplied by z, and make them dependent with each other, even though by the look of it, they are just a normal distribution. Why just a normal distribution? You can calculate, say, the probability of x equal to a and y equal to -a. The chance is 0.5% because of z. Same for that, because z is going from going as either -1 or 1. This is usually not equal to that. Thus, by this example is dependent. However, if we inspect the correlation, the standard deviation is 1. The covariant, which is this covariant, is the expectation of x minus the mean, which is 0. Y mean is 0 as well. And the probability of this is the probability of the x of equal to x, and then there's a half chance y is y equal to x, half chance y equal to -x. So those add together equal to 0. Then we end up getting a 0 covariant and thus 0 correlation. On the right hand side, the plot, let's zoom in a bit. It is a Gaussian of x, a Gaussian of z, a Gaussian of y, where y equal to xz and z is -1 or 1 with a half probability. And if we plot out the heat plot of x and y, this is just a comparison, like both are normal independent Gaussian. This is what you expect. You will just see a heat plot of that, like just like a ball in the middle, and then it's like a 2D Gaussian, right? And as you imagine, there will be a cross because this is the location of x equal to y and x equal to -y, because those are only part, and then the x will be normally distributed, and they're just only the rest are all 0, but here and here will give you a count for all the possible the distribution, because the rest are all 0 because of this function. So zoom out. We we found out that the independence, this example give us a correlation equal to 0 does not necessarily means independence. And this shows clearly of why.